we were talking about that this wave, right? This wave equation. Suppose there is an electric field which is propagating along x-axis, and the equation of wave is always given as amplitude into sine of something. This is amplitude, okay? Amplitude into sine of some angle, okay? Kx minus omega t, okay, or omega t minus theta, okay, something like that, right? Okay, so and by looking at the form of writing a wave, we are writing the equation of electric wave as E naught into sine of kx minus omega t, right? Okay, and similarly, we are writing the equation of magnetic field, right? So magnetic field equation will be written as B naught into sine of kx minus omega t, right? Okay, now if I ask you what is the maximum value of Ex, what is the maximum value that can be possessed by Ex? Okay, then what is the maximum value of this expression? The maximum value of this expression is E naught. Since E naught is constant, okay, and the maximum value of sine of theta, this complete thing, this complete thing is inside of sine, right? This complete thing is inside of sine, right? So maximum value of sine of anything is equals to 1 max. Okay, this maximum value, because we know sine theta is lies between values minus 1 to 1, right? So similarly, the maximum value of Bz will be B naught, right? These are maximum values, right? You should be knowing these things. Okay, okay. So now one more thing I want to share with you, that whenever you see there is an expression like is like kx minus omega t, right? And some expression will be like omega t plus kx, or suppose, don't take it like this, like here I have written kx minus omega t. Okay, suppose a wave is written like here, like e naught into sine of kx plus omega t. Okay, what is the difference between these two? What is the difference between these two? The difference between e naught kx minus omega t and kx plus omega t is the difference is that this wave is propagating along positive x-axis, and this wave is propagating along negative x-axis, right? How? Look, if you do like this, kx minus omega t equals to 0, then x will comes out to be positive, right? And if you do kx plus omega t equals to 0, then x will comes out to be negative, right? So if x is negative, then it is propagating along negative x-axis, and if x is positive, it is propagating along positive x-axis. Correct? Understood? The sign of theta which should be maximum at 1. Okay, so maximum values will be 1, and this thing, the inside the argument, this theta is called the argument of sine, right? The angle of sine, argument of sine, right? So if this argument is like kx minus omega t, and one argument is like kx plus omega t, so you should be able to differentiate what is the difference between these two waves. Okay, suppose there are two equations. One is written as e naught into sine of kx plus omega t, okay, and suppose somewhere written as e naught sine of omega sorry kx minus omega t, and you have been asked that what is the difference between these two waves. Are these two waves same? You will say no. These two waves, one wave is propagating along this is propagating along negative x-axis, and this, when there will be negative in between, there will be, if there is negative in between, if we equate it to be 0, then x will come out to be as positive, so it is propagating along positive x-axis. Okay, I hope you understood the difference between the two. So now if you have understood, if as I hope you have understood till now, then if I ask you now that suppose there is an expression like kz minus omega t, right? And some suppose there is an expression like kz plus omega t, and I ask you what is the difference between these two, then you will say, sir, this if we equate it to zero, then z will come out to be positive. Then I will say that it is propagating along positive z axis, and it is and here z will come out to be negative if we equate it with zero. Then this equation is propagating along negative z axis since here there is z, right? And similarly in case of y also, right? So you should be able to see the wave and answer what the wave is telling you, right? So here ex equal to e naught to sin x minus sin of kx minus omega t. This is the equation of a wave. And what is this equation telling you? The maximum value which can the maximum value of electric wave is E naught. The maximum value of electric wave is E naught, and this wave is propagating along x-axis, and which direction? Positive x-axis or negative x-axis? Positive x-axis. What is this equation telling? The maximum value of B magnetic field is B naught, and it is following sine wave pattern, and the wave is propagating along positive x-axis. Look, in both cases, I have written negative in between. So both wave are propagating along positive x-axis. Right? Okay. Understood? I hope you understood. Right? This is the maximum value. If I want to show it in the diagram, look, just for one wave, suppose it is an electric wave, it is following sine wave pattern. So there is a sine over here. Okay, the maximum is E naught, means suppose it is E and this is X, obviously. Okay, so E naught. This is maximum E naught. Sine maximum value at 90 degree, right? Is E naught. It's 1 over here. Okay, so like that. Okay, so this was the extra thing I wanted to tell you, right? I hope you can take the screenshot or anything. Okay, I'm changing the slide. So this was about wave equation. Okay, wave equation. As we are learning electromagnetic waves, so at least we should be able to decipher what is a wave saying, equation of a wave telling us. Okay. So now I hope I'm giving you more 5 seconds to take the screenshot if in case you have not. Okay, then now what we will study is the peak value. What is the meaning of peak value? Peak value. Oh, peak value. Peak value of what? Peak value of electromagnetic wave. So E naught will be equals to C B naught. And what is C? C is velocity of light. Okay. So E naught is related to B naught as like this. We have seen the equations. Ex equals to E naught into sine of kx minus omega t. And one equation we have seen Bz, one is electric field, one is magnetic field. Okay, B naught into sine of kx minus omega t, right? So here E naught and B naught are related. How? Like this, by this equation. So this equation is important for you. Take a note of this equation. Okay, E naught is related to B naught as E naught is C into velocity of light into maximum value of magnetic field, right? Okay, so as we know that velocity of light, okay, light is an electromagnetic wave, right? So velocity, light doesn't require any medium to travel. Okay, it can travel in vacuum also, correct? So its speed, velocity of light, its speed means if we want velocity is magnitude plus direction. Okay, and if you talk about magnitude only, then it is speed. Okay, if we just take consideration of the only the magnitude of the velocity, okay, of the light, okay, as of now the direction is not our point of concern. The magnitude of velocity of light, the actual speed, is given by the expression mu naught into e naught. And what is mu naught into e naught? Mu naught is the permeability, magnetic permeability, and it is the electrical permeability, right? We know that. What is the value of epsilon? What is the value of mu naught? Okay, just put it, it is the velocity of light in vacuum, okay, or free space. Okay, now if I ask you, you may ask then what is the velocity of light in any medium? In any medium, okay, suppose it is a mu naught is the permeability of free space, then what is, if some medium is there, then it will have relative permeability, then mu naught into relative permeability will be the permeability of that medium, right? It is a relative permeability. Okay, so overall the expression will become mu naught into mu r into epsilon r into epsilon naught, right? Okay, it's simple. Okay, and if there is a non-magnetic material, if there is a non-magnetic material, suppose there is a non-magnetic material, okay, magnetic material, for non-magnetic material mu r is equals to 1, okay, relative magnetic permeability is 1, right? So now going to the next topics. Okay, so if we do some math over here, so absolute velocity of light in free space by velocity of light in any medium will be equals to mu r into epsilon r. Look, divided mu naught e naught, this two things will be uh, cancelled out, and only the remaining thing will be mu r into er. Okay, so it will come like this. So velocity of light in free space to velocity of light in many medium is related to this equation. So this equation is also important for you. So we have studied two equations, the second equation, this is the first equation. What is the first equation telling? This is the relation between these two things. And what is the relation of second? What is this thing? This is the relation of speed of or velocity of light in any medium and in free space. Okay, these two things are related by this equation, and these two things are related by this equation. And I hope how the things are getting related, you are getting it. Okay, and what is this C naught? What is this C naught? C naught is the velocity of light in free space or vacuum. It is given as absolute permeability. Okay, in free space there is no medium. If there comes any medium, then relative permeability will come into picture. Okay, we will multiply the absolute with relative, then we will get the permeability of our required medium, right? Okay, and if there is non-magnetic material, then mu r is equal to 1. Just put mu r equal to 1. Okay, nothing else. So these two equations should be remembered and should be used correctly, right? Now we will look forward to the next equation of our class. Okay, we till now we have studied four properties. Okay, first one is oscillating, there should be an oscillating charge. Okay, there should be an oscillating. there should be an oscillating charge over here, and second is uh, second is no material medium is as such needed. Okay, you it can be there, but it's not needed. Okay, it is not there that there should be some medium over there, then only it can propagate. That is not. Okay, and third was if E is going along X, B is going along Z, then electromagnetic wave will propagate along Y. Means the perpendicular component will be there. So in actual, what is happening? The direction of electromagnetic wave will be perpendicular to perpendicular to the direction of E cross B. It's not B cross A. Always remember, E vector product of E cross B will never be equals to B cross A, right? But it's true for dot product. E dot B is equals to B dot A, but E cross B and B cross A will never be different, because E cross B will be upward and B cross E will be downward. The direction will be completely different. What will be the relation of the direction if we exchange it? E cross will be equals to negative of B cross A. Okay, B cross A. Okay, the direction will be completely opposite to each other. Okay, so now we will consider the fifth property of electromagnetic wave, right? So electromagnetic wave will carry energy and momentum, obviously. Okay, and can we directly answer what is the energy of electromagnetic wave? No. Why? Because we don't have the direct relation as of now, right? So we will go towards the energy, finding energy by calculating energy density. We already have the expression of energy density. Okay, so we will calculate energy per unit volume. Energy per unit volume means per unit volume how much energy is there. Okay, it's called energy density, right? Energy density. And how it is given? Like this: energy per unit volume. Okay, okay, so it is given as half epsilon E square plus half B square by mu. No. Right? How, sir? How it is given like this? Because when we have studied electrostatics, okay, and we were dealing with electrostatic potential and electrostatic energy, there we have read the energy density. If you have not read, then we will go towards electrostatics. When we will go towards electrostatics, studying it once again, we will go through this topic once again. Okay, the energy density of an electric field will be equals to half epsilon E square, right? And the energy density of a magnetic field will be always equals to half B square by mu. Okay, the absolute permittivity into B square. Okay, so with we know our equation was Ex equal to E naught into sine of kx minus omega t, right? And the second equation was Bz equals to B naught into sine of kx minus omega t, right? So here what we will write, half epsilon Ex square plus half Bz square by mu naught, right? Okay, understood? This is du by dv. Okay, I will write this properly. Du by dv means change in internal energy by change in volume. It's equals to u by v only, right? The dimension is not changing. Okay, so du by dv is equals to 1 by 2 epsilon E square, here x, as our equation was Ex equals to E naught sine of kx minus omega t, and B was Bz equals to B naught into Kx minus omega t, right? So here it will be half Bz square by mu naught, right? Okay. बंद कर दिया आंसर. So we are studying that the average energy density, if you calculate the average energy density, okay, average energy density means total energy per unit volume. Okay, it's average energy density. So for to calculate it, we have to go by this differential equation. D del u by del v, okay, del u by del v is equals to 1 by 2 epsilon ex square plus 1 by 2 bz square by mu naught. Okay, then we know we will put the expression of ex. What is ex? Epsilon e naught into sine of kx minus omega t whole square, correct, plus 1 by 2 bz is b naught into sine of kx minus omega t whole square by mu naught, correct. So if I expand this equation, 1 by 2 epsilon e naught square into sine square kx minus omega t plus 1 by 2 b naught square by mu naught into sine square kx minus omega t. Okay, and as you are a math student, you should know the average value of sine square theta. What is the average value of sine square theta? The average value of sine square theta will be always equals to 1 by 2, right? The average value of sine square theta. Okay, so if average value of sine square theta is 1 by 2, okay, then what we can write over here, what is UAV, total average energy by total volume, will be equals to, if I substitute 1 by 2 in place of sine square kx minus omega t, as why we are doing so, because we are calculating average. Okay, so average value we are substituting in place of sine square theta. Okay, so it is coming out to be 1 by 2 epsilon e naught square into 1 by 2 plus 1 by 2 b naught square by epsilon into 1 by 2. So expanding this equation, we will get 1 by 4 epsilon e naught square plus 1 by 4 b naught square by mu naught. Here it is e naught square. Okay, so from this equation we can see that the average energy density can be given as 1 by 4 epsilon e naught square plus 1 by 4 b naught square by mu naught, correct, right? So what is this? This is this part, this is total average energy by volume. Okay, this is the average energy of electromagnetic wave. Okay, average energy of electromagnetic wave. Then what is this? Average energy density of electric wave. And this is average energy density of magnetic wave, correct, or magnetic field, you can say, right? And if we add the average of two electric field and magnetic field, both the averages we will, if we will take, then we will get the average velocity of electromagnetic wave, as electromagnetic wave is made up of electric field and magnetic field, right? इसको बंद कर दिया. Okay, so now proof. if you want to play with these equations, then we will see one fun that let us prove, let us prove, let us prove. But the in any plane, in any plane, in any plane, electromagnetic wave, okay, average energy density, average energy density of electric field is equals to average energy density of magnetic field, right? Correct. How can we proceed over here? Take LHS, prove RHS, simple, right? So how can we do this? Average energy density of electric field is 1 by 4 epsilon E naught square. Just now we have seen this, right? How can we change it? Now look, 1 by 4 epsilon E naught square can be written as 1 by 4 epsilon naught E naught square can be written as, look, what is this? Average energy density means energy by volume. Okay, energy by volume. Correct? Am I clear? Right. So we know that E naught was related to B naught with the equation E naught equal to CB naught. Right? Always remember this equation. Right? E naught is equal to CB naught. Right? So put it over here. Simple. 1 by 4 epsilon naught into E naught square. So here C square B naught square will come. And what is the expression of C square? 1 by 4 epsilon. What is C? I have told you C is 1 by root over mu naught into epsilon naught. In the previous slide, you can go back and see 1 by root over mu naught into epsilon naught whole square into B naught square. Just open the under root, do the square, and you will get the answer. 1 by 4 epsilon into 1 by epsilon into mu naught into B naught square. Here epsilon is cancelled, is equal to 1 by 4 B naught square by mu naught. It's equal. Here it is average. Here, but we got over here average energy density in magnetic field. From where we had proceeded? Average energy density of electric field. So we have proved that average energy density of electric field is equals to average energy density of magnetic field. Happy? It is equals to average energy density of magnetic field. Okay. Oh, sorry. Magnetic field means mu naught will be there, and it's right. These two are equal. How? This is the proof. Correct. Just put this equation over here. Put the C value, and you will get the answer. Right. So going to the last topic of our discussion, intensity of electromagnetic wave. It's important, right? What is intensity? What is intensity? A electromagnetic wave, right? Intensity is energy crossing per unit area per unit time. This is intensity of any wave. Simple. Intensity is always given by the energy of a wave going through some particular area in some amount of time. This is the intensity, right? And this is E is not electric field. This is the energy of a wave. This is energy. Okay, energy per unit area by volume. And how it can be written? Energy per unit time is power. Energy per unit time is power by area. So intensity is equals to energy per unit area per unit time, or it can be written as power per unit area. So both the equations are important for you. Till now you have got 4 equations. I hope you will remember those 4 equations, as I will give some related things in homework also, right? So I equal to energy per unit area per unit time, right? So I equals to power by area. Okay. Intensity of electromagnetic wave we are studying, right? So this is the just the formula. Okay, I have just mechanically given you the formula that intensity of any wave, energy of that wave falling on a surface. Suppose a wave is coming, falling on a surface, on unit area it is coming. So energy per unit area in one amount of time. Okay, per amount of time, 1 second. Okay, whenever time comes in denominator, it is telling us the value, telling us everything is happening in 1 second. Okay, keep that in mind. Power is always energy consumed per second. Okay, per time, per minute, per hour, right? Okay, so I average in average intensity, always we won't ever get correct intensity value. Average intensity, whole in whole means, okay, average intensity how we can write it. Just we will see how we can calculate average intensity. But for this time, okay, I will explain you how to deal with the formulae and to get the right dimension of the equation. Okay, so that you should have a clear understanding about the equation is going right or wrong. Okay, in average intensity will be half energy, right? Energy half epsilon e square, e naught square, into C naught. How, sir? Only this. And this area divided by time, everything is consumed over here. Everything. Why? We now I have giving you the reason. We know energy density. Energy density is energy per unit volume. Okay. Energy per unit volume. Okay. Here energy per unit volume of electric field is energy density of electric field is given by 1 by 2 epsilon naught e square. I have given you. Go to the previous section and just see energy density of an electric field. I'm not talking about average energy density. Now energy density. Okay, energy density of 1 by 2. From energy density we have calculated average. Okay, so energy density is given by 1 by 2 epsilon naught e square, and for magnetic field it is given as 1 by 2 b square by mu naught. Okay, in average it comes out to be 1 by 4, as everything remains the same, right? It is the energy density. Energy density is energy per unit volume. Here it is energy per unit area. Okay, right? Energy per unit area means meter square is there. Meter square is over here. Okay, meter square over here, and we are doing it meter cube. Okay, we are placing it here energy by meter cube. So 1 meter is extra we are placing over here, right? 1 meter is extra we are placing over here, so we have to cancel it. So here we are multiplying with 1 meter, one length, and that time is already there, delta t. So time is in seconds. So c naught is what, meter per second or not? So dimensionally it is perfectly fine. What is the average intensity? 1 by 2 epsilon naught e naught square into c naught. I hope I have given you a good brief explanation of how dimension is fitting this equation correctly. Okay, if you are not understanding it, just rewind 5 to 10 minutes, 5 minutes or 1 to 2 minutes, and just listen to the explanation once again. Okay, just try to understand what is happening. So here area is there, so meter is there, right? Meter square is there, and we are placing meter cube over here, and we are placing meter cube over here, right? So as we are placing 1 meter more, we have to cancel it one by placing over here 1 meter in numerator. One length we have to cancel it over here. One length we have to cancel it. So as we have multiplied one length over here, so this length by second is speed, and that speed can be represented as c, right? Velocity of light. So average intensity, average intensity is 1 by 2 epsilon naught E naught square into C naught, right? For electric field. So average intensity of magnetic field will be half B naught square. There mu naught comes in denominator into C naught. Simple. Okay. Now we will, you must be having some doubt that how it is coming up. Okay, how it is coming. I just want to understand how I is equal to energy by area into time is equals to power by area is equals to half epsilon naught E naught square into C naught, or half epsilon naught B naught square by mu naught into C naught. Just going through the derivation. It is the last topic. Don't worry. Just 5 minutes more and we will be done. Okay. So suppose this is an area, okay, through which wave is going on. Okay. This is our x direction. Okay. The velocity is c naught. So in delta t, in delta t, in delta t time, in time, in, understand the condition properly. In time delta t is some amount of time. Okay. All the energy present in length, all the energy present in length, c naught into delta t. What is c naught into delta t? Speed into time. What is speed into time? Distance. Distance equal to speed into time. So in time delta t, in some seconds or some minute, all the energy present in the length c naught into delta t. This is c naught into delta t. Okay. All the energy c naught into delta t. Okay. In the length c naught into delta t. Okay. Will pass through the cross section area in time delta t. Hence, total energy crossing, total energy crossing in this time delta t will be equals to, will be equals to U equals to total energy. This is total energy. Okay. 1 by 2 epsilon naught E naught square into total energy is average energy density is energy by volume. So total energy will be into volume, right or wrong? So into volume is 1 by 2 E naught epsilon naught E naught square into volume can be written as, volume can be written as, volume can be written as meter cube. Okay. Meter cube. Okay. Meter cube. So dimensionally over here it should be meter cube. Otherwise everything is over same. Okay. Just we will try to write this thing in a different manner over here. Okay. Okay. So volume is area into length. Okay. So area into length. Okay. So it is basically meter cube. Sorry for the interruption. So what we will write over here, we will write C naught into delta T into area. You remember the expression? What we have written in the first place? I intensity average is equal to U by A into delta T, right? So that from that A into delta T we are writing over here. Okay. So how this expression is fitting volume? Volume is equal to, I can write it like this. You will say how? Look, C is velocity. Velocity is meter per second into delta T. Delta T is second into area meter square. Look, ultimately it is meter cube. It's equals to dimensionally is equals to volume. Right? Accepted? So 1 by 2 epsilon naught E naught square into C naught delta T into area. So if I now calculate, it is U average. So if I calculate energy per unit area per unit volume, per unit time, means U by A into delta T will be equals to per unit area per unit time. This per unit area, this will go here. So U by A into delta T will be equals to, look, 1 by 2 epsilon naught E naught square into C naught. A into delta T have gone in the denominator over here. Look, now you got it. Why I was saying so over there in the last slide. Okay. U average is equals to this. This will come in the denominator. And if I take this in the denominator of U average, it is energy per unit area per unit time is equals to this. And this is intensity. What is intensity? U per unit area per unit time or not? So U per unit area per unit time is equals to 1 by 2 epsilon E naught square into C naught. Correct? So this is the important expression, intensity of a wave. Just remember this. So 5 or 6 equations we have seen. Just remember all the things and just be clear with the idea from how and why the equations are coming and how it is fitting the equation. Okay. You should know very clearly that how we are replacing and why we are replacing and how the replacement of C naught delta T into A is correct for volume. Okay. Because dimensionally it is fitting. Okay. And this line is not by. Okay. This is just nothing is there. Okay. See, not everything is in the same expression. So this is all for electromagnetic wave. If some topic is left, then let me know. Okay. This is the continuation of previous slide. Just go through the lecture once again. If you find any difficulty, then if you find any more doubts, then ask me. Okay. Just electromagnetic wave is completed from my end. If anything is left, then just tell me with the topic. I will cover it. Okay.